Hi there. I'd like to work a problem about expected value for you to help you better understand what it means. The example I chose is the one here. It reads, the number of standby passengers who get seats on a daily commuter flight from Boston to New York is a random variable x with a probability distribution given below. So here we have the probability distribution, and unlike the examples we've worked so far in the notes, you can see that this entire probability model was essentially given to you. You didn't have to build it like we did with the marble game or with the 3 children example. This one, we were told that the random variable can take on the values from 0, being no people were able to get a standby flight, all the way up to 5 were able to fly standby on this particular flight. So, and more importantly, the associated probabilities. No way we would know this. This is based off of historical data from the airline. Now, one thing we want to check, they told us it was a probability distribution, and I can kind of see we have all probabilities here between 0 and 1. The final check is to see whether these probabilities add up to 1, and indeed they do. So we have a legit probability model in front of us. Now, what we want to do is now take this a little deeper and try to find the expected value of this probability model. The mean, what we expect to happen on average if we looked at a lot of situations of this flight using this probability model. So again, we want to find the expected number of standby passengers who will get a seat. So here is our table. I've added a third column. You'll see in a minute why I added it, but it's the same information in the first 2 columns in the slide prior. Now, expected values, down here's a formula for it, is x times p of x. So we have this product here, and then we're going to sum all those products up, add them all up with this big sigma here. So that is why I've created this third column called x times p of x. We're essentially going to multiply the values in the first column times the value in the second column in each row. So we'll have 0 times 0.30. That's an easy product. That's 0. 1 times 0.25, another easy product, 0.25. 2 times 0.20, that's 0.40. 3 times 0.15, that's 0.45. 4 times 0.05, 0.20. And finally, 5 times 0.05, 0.25. So we have created all these products, and as we can see here, the mean tells us we need to add them up. That's what the sigma means. So if we add them up, our mean is 1.55. So what that says is that if we looked at a lot of these, indefinitely looked at a lot of this particular flight, and recorded every time how many people were allowed to get a standby seat, we would see that on average, 1.55 seats were given per flight. That's what an expected value tells us. Again, if we looked at a lot of these and recorded how many people were able to get a standby flight, on average we would see that 1.55 people were able to get a seat per flight.